Hi friends, this is Hemant sir. I hope you all are safe and enjoyed this Diwali vacation. In the last video session, we have seen preparation of carboxylic acid from the aldehyde, ketone and carboxylic acid chapter. Let's see the next point from the again lesson number 12, aldehyde ketones and carboxylic acid. The point name is chemical reactions of aldehydes and ketones with nucleophiles. The first reaction, addition of hydrogen cyanide. Second reaction, addition of sodium bisulfite. And third reaction, addition of alcohol. In this session, we will discuss these three reactions. This all the reactions are addition reaction and all the reagents are nucleophile. So let's start with the first reaction, addition of hydrogen cyanide. Let's see the first chemical reactions of aldehydes and ketones with nucleophile. Aldehyde and ketones, we know that both have the carbonyl group and highly polar compound. Aldehyde is more reactive than the ketone because of less steric hindrance in aldehyde. Hence, aldehyde is more reactive than the ketones. Nucleophile means a nucleophile is a chemical species that donates an electron pair to form a chemical bond in relation to a reaction. Here, a nucleophile have always extra lone pair of electron to donate. Nucleophile is also called as a Lewis base. This extra lone pair of electrons donated to the electrophiles because Lewis base having the extra lone pair of electrons, hence he can donate the electrons. Here, let's see the first. Here, in all this reaction, the nucleophilic reagent brings about reaction by attacking on positively polarized electrophilic carbonyl carbon in aldehyde and ketones. Let's see the first reaction, addition of hydrogen cyanide, HCN, hydrogen cyanide. H acquire having delta positive charge and cyanide acquire having delta negative charge. Hydrogen cyanide here act as a weak acid, acts across the carbon oxygen double bond in aldehyde and ketone to produce compound called cyanohydrins. The negative part of the reagent We know that cyanide having the negative charge on it. The negative part of the cyanide attack the electrophilic carbon of carbonyl carbon. The reaction requires either acid or base as a catalyst. Let's see how the reaction actually happen. Okay, this is ketone or maybe aldehyde. This R dash can be hydrogen or alkyl or aryl group. Means you can consider aldehyde, ketone, aromatic ketone. Clear? In short, we can use a carbonyl group instead of aldehyde or ketone. Okay, this carbonyl group is a highly polar. This oxygen having delta negative charge because in this structure the oxygen is a highly electronegative atom having delta negative charge on it, and carbon atom having delta positive charge on it. This both are this R is a electron donator group. R means alkyl group donating the electrons towards the carbon. Okay, hence the carbon pushes the electron towards the oxygen because of the his electronegativity property. Clear? Here this carbonyl group react with the weak acid like hydrogen cyanide. Hydrogen cyanide, the hydrogen acquire delta positive charge and cyanide acquire delta negative charge with extra lone pair of electrons. Okay, hydrogen acquire delta positive charge and cyanide acquire delta negative charge. Clear? Now this negative part of the reagent attacks the electrophiles from backside like this way. Okay, a pi electron shifted towards the oxygen like this way. Once the cyanide formed the bond between the carbon, a pi electrons which are loosely bounded with the carbon and oxygen is break and shifted the electron towards the oxygen. Then oxygen acquired delta negative charge with extra lone pair of electron because pi electron shifted towards the oxygen. The carbon is actually sp2 hybridized carbon atom having planar geometry. Okay. Once the pi electron shifted towards the oxygen due to the cyanide, the negative part of oxygen donate the electron to the hydrogen. Clear? The resulting structure will be cyanohydrin because the structure having cyanide as well as the hydroxyl group. Hence the structure name will be cyanohydrin. How actually happen this? See, we know that in the Markovnikov's addition reaction, what was the statement of the Markovnikov's? When an unsymmetrical alkene react with the unsymmetrical reagent, the negative part of the reagent will approach toward the carbon, which carries less number of hydrogen atom. But in the structure, there is no hydrogen. Correct? So this law will not be applicable here, but the negative part of the reagent will attack on the electrophilic carbon atom. Correct? See, carbon acquired positive charge and oxygen acquired negative charge. And hydrogen acquire positive and cyanide acquire negative charge. The negative part of the reagent, this part, the negative part of the reagent of cyanide approach toward the positive part of the aldehyde or ketone. Once the bond formed between the carbon and cyanide, a pi electron shifted toward the oxygen and oxygen donated the electron to the hydrogen. A bond formed between the oxygen and hydrogen like this. OH formed this one. And a carbon and cyanide bond formed this one like this way. This both the R and R dash is as it is. No change on it. Example. This is the acetaldehyde. When this acetaldehyde react with again hydrogen cyanide, the negative part of this reagent here approach towards the carbonyl carbon like previous reaction. Let's see how this negative part and this is the positive part of the reagent. A carbon having delta positive charge on it and oxygen having delta negative charge. This negative part with extra lone pair of electron approach toward the carbonyl carbon. A electron shifted, pi electron shifted toward the oxygen, and then the hydrogen means oxygen donated the electron to the hydrogens. You will get the cyanohydrin. Okay, this is acetaldehyde cyanohydrin. Why? Because acetaldehyde cyanohydrin, because as a starting product we use here acetaldehyde, hence it is acetaldehyde cyanohydrin. Next reaction with the ketone. Let's see ketone. This is the common name of the ketone, that is acetone. When this acetone again react with the cyanide, see this negative part again positive, this positive, and this part is a negative. Okay, see here this negative part approach toward the carbon is very easily. There is no more energy required to reach toward the electrophilic carbon atom. But here the hydrogen cyanide takes more energy to reach towards the electrophiles because of the bulkier group. There are two bulkier group. Hence, this cyanide approach from the backside of the carbonyl carbon. A pi electron shifted again towards the oxygen. Oxygen donated the electron to the hydrogens. It gives the acetone cyanohydrin. I hope this topic will be clear to you. It is simply nucleophilic addition reaction. As a nucleophile, we use here hydrogen cyanide, and as electrophile, we have used here aldehyde and ketone. Let's see the next reaction. See here, the carbon is sp2 hybridized penor carbon atom. This is sp3 hybridized tetrahedral carbon atom. ये आपको पता ही चल चुका. Let's see the next reaction, that is addition of sodium bisulfite. Aldehyde and ketones react with the saturated aqueous solution of sodium bisulfite to give crystalline precipitate of sodium bisulfite. It is a white crystalline precipitate of the sodium bisulfite. It is simply addition reaction. Let's see the reaction. When this acetaldehyde react with the saturated aqueous solution of sodium bisulfite. This is sodium bisulfite. We know that this sodium acquire positive charge and always here SO3H acquire delta negative charge. Okay, it is simply nucleophilic addition reaction because sodium hydrogen sulfide is act as a nucleophile, and here ketone or aldehyde both are act as a electrophile. Again, same like previous reaction, this negative part approach toward the carbonyl carbon. A pi electron shifted toward the oxygen. Oxygen donated the electron to the sodium. It gives the acetaldehyde sodium bisulfite. Adduct. Adduct means addition reaction. It is adduct. Okay. Then let's see with the ketone. What will be the product? Can you imagine? Again, acetone. C. Acetaldehyde gives acetaldehyde sodium bisulfite. Acetaldehyde gives acetaldehyde sodium bisulfite. Same acetone gives acetone sodium bisulfite. Let's see the reaction. Acetone react with the saturated solution of sodium bisulfite. Okay, it gives a white crystalline precipitate of acetone sodium bisulfite as addition product. I hope you will be clear for this reaction. नेक्स्ट रिएक्शन देखते हैं. लास्ट रिएक्शन, that is addition of alcohol. Aldehyde react with one molecule of anhydrous monohydric alcohol in presence of dry hydrogen chloride or gas it, to give alkoxy alcohol known as a hemiacetal, which further react with one more molecule of anhydrous monohydric alcohol to give a geminal aldyl alkoxy compound known as acetal. Let's see the reaction part. It is also addition reaction. Okay, this is aldehyde. We can say acetaldehyde. When this acetaldehyde react with the alcohol, this is alcohol aldehyde. This aldehyde, this part is aldehyde and this part is alcohol. Alcohol acts as a nucleophile here. This reaction is carried out in presence of dry HCl. Okay. Now this ROH dissociated like this way. A hydrogen acquire positive charge and RO minus. RO acquire negative charge. Okay. This negative part will approach toward the carbonyl carbon. Pi electron again shifted towards the oxygen. Oxygen donated the electron to the hydrogen. We will get the hemiacetal. It is unstable molecule called as the hemiacetal. Okay. Here in this structure there are alkoxy group as well as the hydroxy group are present. See here. This part is the alkoxy and this part is a hydroxy group. Both are there. Hence there is a little bit a steric hindrance between the two oxygens and hydrogens. There will be intramolecular hydrogen bonding, hence it is unstable. Again, step second. When this unstable hemiacetal again react with the same molecules like alcohol, it is further addition reaction with the hemiacetal. Then again, this alcohol again dissociate this way. RO acquire delta negative charge again, and hydrogen acquire positive charge on it. What happened here? This hydroxy having extra lone pair of electron. This extra lone pair of electron donated to the hydrogens and it formed the water molecule OH2. करेक्ट. एक हाइड्रोजन इधर है और एक हाइड्रोजन इसको इलेक्ट्रॉन देता है तो OH2 मिलता है. तो ये वाटर मॉलिक्यूल निकल जाएगा. A water molecule released from the carbon and carbon now bearing positive charge on it. Reaction again carried out in presence of dry HCl and dilute HCl. Once the water molecule, yeah, you can say dehydration reaction take place, but the negative part, this negative part approach toward the a positive part of the carbon atom, you will get the acetal. This two alkoxy group, due to the two alkoxy group, it is called as a acetal. Okay, which is stable than the hemiacetal. Acetal is stable than the hemiacetal. There is no any kind of the intermolecular hydrogen bonding between them. Hence, it is quite stable. Let's see the example. Step first, acetaldehyde. When this acetaldehyde react with the ethanol, again dissociate like this way. This one is ethoxy and hydrogen having positive charge on it. This negative part will approach towards the carbon. A pi electron shifted towards the oxygen. Okay, you will get the hemiacetal. Hemiacetal, always keep in mind the structure having one hydroxy group as well as one alkoxy group. Here in this structure, this is ethoxy and this one is a hydroxy. Then this hemiacetal further react with the alcohol in step second in presence of dry HCl. This OH donated the electron to the hydrogen and this alkoxy part will approach toward the carbon due to the electrophilic carbon atom. You will get the 1,1-diethoxy ethane, that is stable product. We can say acetal. Hope this is clear to you. This is most important reaction of chemical reaction of aldehyde and ketone with the nucleophile. Clear? Similarly, ketones react with the alcohol in presence of acid catalyst to form hemiketal and ketal. Here, ketones react with 1,2 or 1,3 diols in presence of dry hydrogen chloride to give 5 or 6 member cyclic ketal. The reaction can be reversed by treating the cyclic ketal with the aqueous HCl to regenerate the ketones. Acetal and ketals are hydrolyzed with aqueous mineral acid to give the corresponding aldehyde and ketones. Let's see the reaction. This ketone, this is called as alcohol. There are two hydroxy groups, hence it is called as a diol. A two hydroxy group, hence it is called as a diol. There are two carbons, hence it is ethane. The position of the hydroxy group is 1 and 2, hence it is ethane 1,2 diol. Clear? Again, this lone pair of electron shifted towards the carbon. Then pi electron shifted towards the oxygen. Then oxygen donate the electron to the hydrogen. You just imagine what will be the form between the carbon and oxygen and hydrogen. A one bond form between the carbon and oxygen, a single bond form between the carbon and oxygen and hydrogen acquire one bond. Same thing here. A pi electron shifted again the carbon. Here the hydrogen donated the electron to the oxygen donated the electron to the hydrogen. A water form here. Water molecule released from the electrophilic carbon atom, and then carbon bearing positive charge, and then the negative part of this oxygen approach toward the carbons. You will get this cyclic kettle structure. Clear? See, this part is the same as it is. There is no any kind of the change. Okay, this oxygen and hydrogen, there are two hydrogen released from the structure. Here, see, this one oxygen and this two hydrogen atom released and bond form between the, like this way, carbon and oxygen. Clear? You will get the cyclic kettle. Very simple reaction. Ketone gives the kettle. Clear? It is very simple reaction. Cyclic kettle is used as protecting group for ketone in a reaction of multifunctional compound to which ketone is sensitive. I hope you understand well. In this session, we have completed chemical reaction of aldehyde and ketones with nucleophile. The first reaction, addition of hydrogen cyanide. B, addition of sodium bisulfite. And last is the addition of alcohol, giving hemiacetal and acetal. Clear? Thank you for being with us. Bye bye.